make a bet with you without knowing a single thing about you. My claim, your friends have, on average, more friends than you do. Sounds like an insult, I know, maybe even like nonsense, but I win this bet against almost anyone alive. Someone once ran the numbers on all of Facebook, 721 million people, and for 93 out of 100 it holds. The average person had 190 friends. Their friends? 635 on average. Almost everyone is less popular than their own friends, and that's not bad luck, that's math. This is the friendship paradox. A sociologist wrote it down in 1991, and it has passed every test since, in almost every friend group, in almost every network on Earth, a school class, a sports club, social media, you sit below the average of your friends. Not sometimes, almost inevitably. And the wild part isn't the number. The wild part is, it can't possibly be true for everyone at once, can it? And right there, your head pushes back, and it's right too. Because everyone is below average sounds impossible. In a classroom, not everyone can be shorter than the average. Somebody has to pull it up. The trick hides in one word that's easy to miss. Your average and the average of your friends are two completely different numbers. You're not comparing yourself to everyone. You're comparing yourself only to the people you happen to be friends with. And that selection is anything but random. Hold on to the question, which two averages are actually going head to head here? And because it sounds so paradoxical, we trust no one, we check it ourselves. No giant network, no millions, no Facebook, just 5 people, 5 dots, a few friendships between them, small enough to count every number on your fingers. Because if the paradox already shows up with 5 people, then it's not about the internet and not about millions of users, then it lives in the bare structure, in the question of who's friends with whom. So 5 dots, let's draw them. Ada is well connected. She's friends with all 4 others. Ben knows Ada and Sem. Sem knows Ada and Ben. Deo knows Ada and Eli. Eli knows Ada and Deo. Let's count each person's friends. Ada, 4. Ben, 2. Sem, 2. Deo, 2. Eli, 2. The average is quick. 4 plus 2 plus 2 plus 2 plus 2 makes 12, divided by 5, 2.4 friends per person. That's our honest number. Take all 5, share them out fairly, and everyone here has 2.4 friends on average. No trick, just counting. Remember it. Because now comes the part where that 2.4 starts to wobble. Now the other number, not how many friends do you have, but how many do your friends have on average. Take Ben. His friends are Ada with 4 and Seem with 2. Average, 3. Ben himself has 2, so his friends are better connected than he is. Now the same for everyone. Ben, Seem, Deo, Eli, each one comes out at 3, each sits above their own 2. 4 out of 5 are below the average of their friends, in the very tiny network we drew ourselves. All except Ada. Why her, of all people? Look at where Ada shows up. In Ben's friend list, in Sem's, in Deo's, in Eli's. Ada is in every single one, and each time, her big 4 drags the average up. The poorly connected dots, meanwhile, barely appear anywhere. And that's the heart of it. When you look at a friend, you're not drawing a random person. You're drawing someone in proportion to how popular they are. People with many friends sit in many lists, so you run into them more often. The popular get counted many times over, the lonely almost never, and that counting trick quietly shifts the whole average upward. That's why your friends seem more popular. They are a sample of the popular. This fits into a single line. The average of your friends is your own average, plus a surcharge. And that surcharge is the inequality in the network. The more unevenly people are connected, the bigger the gap. That's the whole explanation for almost inevitably. The surcharge is never negative. It hits 0 only when everyone has exactly the same number of friends, and in real networks that basically never happens. The wider the gulf between the connected and the lonely, the sharper the paradox. So as long as somebody is more popular than somebody else, you lose the bet. And now back out of the 5-dot network into the biggest one ever measured. In 2011, researchers took on the entire Facebook graph, 721 million people, nearly 69 billion friendships, the same calculation we just did by hand, only a billion times over. The result, 93% sit below the average of their friends, 190 against 635. A handful of superconnectors with tens of thousands of contacts tip the average for everyone else, the same Ada, just a billion times over. The effect from our mini-network survives all the way up to planet scale, dot for dot the same mechanism, and then it gets genuinely useful. 2009, swine flu is rolling in. 2 researchers ask 319 students each to name one friend, and then watch both groups. The friends are, on average, the more popular, the more connected ones, so they sit closer to the action, and whoever has many contacts gets hit by a virus earlier. The result, the friend group came down with the flu about 2 weeks before the others, an early warning system for epidemics, built from nothing but name me a friend, and the same idea saves lives even more directly. Imagine you want to vaccinate, but you don't know the network, don't know who the hubs are. The trick, ask random people to name one friend and vaccinate the friends. Thanks to the paradox, those are on average exactly the well-connected ones who'd spread an outbreak fastest. You hit the super spreaders without ever having searched for them, no network analysis, no database, just one simple question. A skewed statistic becomes a vaccination strategy. So, are you unpopular if your friends have more friends? No, you're just compared unfairly against a selection where the popular show up many times over. Your friends aren't a mirror, they're a window onto the well-connected. And that's the real lesson. Average sounds like neutral truth, but everything hangs on who you count. It lies more often than you'd think, and there are more stories like it.